So today in class we talked about negative exponents, and what we came to realize was that negative exponents create fractions. Negative exponents are going to create a lot of fractions for you. So base example, we're talking about seeing things such as 9 to the negative fourth power. How do we handle that? And what we realized in class today, real simple, since we now know that it's going to create a fraction. What we realized today, 9 to the negative fourth power is equivalent to 9 to the fourth power being placed in the denominator of a fraction 1 on top. In actuality, if you want to look at it this way, we can represent 9 to the negative fourth power as a fraction by placing it over 1. And to remove our negative exponent, all we really need to do is flip our fraction over. So now we have 1 over 9 to the fourth power. And if we needed to, we could go ahead and simplify this. For the sake of tonight's homework assignment, we're going to leave it this way unless the directions on the homework assignment ask you to simplify or expand. A real simple adjustment, though. Real simple adjustment. A little bit more complicated example, we might see things such as 3y to the negative second power x cubed. So again, we can have one bigger term that's made up of three separate terms here. Again, if we want to clean this up, we want to simplify this a little bit, if you will. We know we're going to get a fraction because we have a negative exponent. And as we proved back here, the negative powers is equivalent to placing those in the denominator. So y going to be moved to the denominator, both of them. X to the third power is already positive, so we're going to leave it alone, so it's going to stay on top. We've discussed the exponent that is here with the 3. Again, there has to be a power here. That is a 1, and again, that is considered positive, so we're going to leave the 3 in the numerator as well. And again, for our purposes, we could say this is simplified. If later, we had some more information for x and y, we would go ahead and maybe be asked to evaluate. But for right now, that's what we need. That's all that we can possibly do here. We'll just leave it at that point. So there's a couple examples of negative exponents and how they relate to just plain simple terms. Expand on this a little bit. 4x to the fifth power times 5x to the negative ninth power. We can expand on this a little bit now, and we can start to see some math problems with negative exponents in it based on what we've done in the past. 4 times 5, we know we're allowed to go ahead and multiply those together. So now we have x to the fifth and x to the negative ninth. And what we discussed in class today, if our bases are the same, okay, if our bases are the same, then what that tells us is we can add our exponents together. We can add our exponents together. So 5 plus negative 9, that is equivalent to 5 minus 9. So our 20 is going to stay. X, 5 minus 9, is the negative fourth power. That will be to the negative fourth power. Again, as we've proved up here, if we have a negative exponent, we want to place those in the denominator. So we can clean this up. We can move the 4x's to the denominator. The 20 has a power of 1, so we're going to keep that in the numerator. Okay? Same concept, just now we're starting to see it as part of the math problem. We could also do the same thing with our big fraction bar. So we could have 24x to the 8th over 3x to the 4th. (24) divided by 3, we know we're going to get an 8. Okay, as we discussed in class today, if the bases are the same, which they are here, the two x's, if we are multiplying them together, we're allowed to add our exponents. If we are dividing, we are going to subtract our two exponents. So bases are the same. We can subtract our powers. So 8 minus 4 would leave us with an x to the 4th power. And so based on the example we have here, there's only a 1 left in the denominator. The 3 got divided out, the x got factored out, so there's really only a 1. So this would clean up to just 8x to the 4th. Much easier to deal with than what we had in the very beginning. So simplifying is going to save us a lot of time there. So hopefully that's enough to get you started on homework tonight. Do the best you always, do the best you can. Bring any questions to class tomorrow. Have a good night.